Thank you. Thank you. Well, I guess everyone is kind of tired this time. Yeah, after a long event, it's been amazing so far. One thing that, yeah, I want to talk about like big mobile code bases, and basically before starting, actually, I asked for something Russian. You know, like I wanted to have some memory out of this place, so I'm gonna introduce myself with just using my head. So thank you. Uh, yeah, that's me. I'm not gonna use it during the entire talk because it's super hot. Actually, it's super nice for winter. But yeah, I'm gonna quickly introduce myself. So my name is Fernando Cejas. It's a pleasure to be here today. As many of you, I'm a curious learner. I'm a software engineer. I work at SoundCloud. I like speaking. I think most of you, are geeky like me. I work at SoundCloud now. And sometimes I write in my blog about specific things, mostly software engineering related. Let me get started with this talk. It's about big mobile code bases. I'm going to take it out for now, but I'm going to just leave it here. It's going to help me. So I usually like to start with a story, with real use cases. And in this occasion, my story begins with, a pet project. Like when all of us like to code, like to have our own side projects. We are happy developers, hacking it up at home or whatever. These projects, it's kind of your baby. You like it. You try out things. You're the only maintainer, of course. You make all the technical decisions. Here, no conflicts. No one has to review your PRs, no comments, none of that, right? So this is something I like to call one-man development process model. So it's you, it's me, we're just hacking it up. And but what happens, if you succeed with this project? At some point, you're at home and then you just ship a first version of that, of a library, of whatever, or an application. And you start growing the project. So the project starts growing, your code base, your little code base with just, a little bit of complexity starts growing. You need more features. For instance, you have more users. And you're extremely happy because, things are starting to be nice. So you're kind of like this guy, all right, now I'm getting popular, my app is there, it's being used by many users. But there is a problem. And I usually say the first problem of any code base or of any project is success. And this is where my talk really starts, because I don't want to tackle small code bases. For me, it's just like something that when you're in a startup, it's way different. So when you're working at a big company, you might see different things. These are real numbers of our Android and iOS app at SoundCloud. So as you can see, we have like 160 million users on Android and 120 million iOS installs. So you can imagine like when you screw it up, you're really affecting a lot of users. And let me tell you like a quick story. I remember when I joined the company, and then I'm going to go later to the release process and how we work with that. But I was by myself, and I was what we call the release captain. So you take care of, the release. And I didn't know much. You're new to a code base. And back in the days, we had a totally manual process for shipping our app. And that's where all the this evolution comes in, and I'll be going, telling you how that happened. But basically, our app back in the days had around like 80 million users, our Android app. And there was a step in the middle that the release captain had to change the endpoint. Instead of pointing to the development version of the API, you had to change that endpoint to point to the production version. So I forgot to do that. And our development process is just 2 Mac minis. Our development API is running in 2 Mac minis. So you can imagine 2 Mac minis serving 80 million users out there. And I remember I shipped that and I went back home. And for some reason I just went running, right? And it was running and I wanted to listen to music. And it's just this is not working. Not playing any sound. And it was pretty curious because our core actually is to play tracks, right? So if that doesn't work, we're completely, I'm not going to say that word, but you know what I mean. So I received a phone call from the CEO of the company saying, all right, I think our Android app is not playing tracks. And someone told me that you are the release captain for this release. I just hung up. I'm gonna quit on Monday when I get to the office. So in the end, this is about mistakes. That's what I'm saying. We make mistakes all the time, especially when we need to scale code bases. And I just wanted to give you this little story because shit happens all the time, and we make mistakes. And and the cool thing about that is honestly, in that situation, there was no finger pointing to me. We made a mistake, and no one actually said it was you. So we, as a team, tackled the problem, we solved it, and then there was a retrospective. So my talk is basically to go through this growing, just this massive growing from having a small application. And what happens when you succeed within your project? Again, your code base grows, but you don't have no tests, probably. Probably you have 0 tests, and there were today a couple of super nice talks about testing, so I'm not going to cover that. But it's something that happens because you're just having fun out of that. So you might say, all right, I'm not going to write any tests. I just want to code and try things out, whatever. What happens? There's also you start you don't have consistency across your code base. You might be, developing a feature in a specific way in this screen, and then you try something new on the other screen. So, that's pretty normal, right? But you get frustrated when you start growing because that has an impact on your code base. And this becomes an unsustainable situation. And I'm going to tell you why. Because you need more requirements. You will have more contributors to that code base. Just a quick question. How many of you have more of 5 Android developers in your team? Or iOS, yeah, it doesn't matter. More than 5. Just, okay. 5 or more, yeah. 10? 10? All right. Nice. 15? Awesome. Okay, cool. So you know what I'm talking about. We are now at some... Huh? All right. Okay. 20? 25? Okay. Good to know then. So you're probably struggling more than me. We are around 20 people on both teams. 20 iOS developers and 20 Android developers. So, we're having a lot of code contribution. You can imagine every day how much code we push, right, to master. And there's another problem. like you need to speed up because time to market is important for you. Since you succeed, then you want to be fast and don't lose this train, that is taking you to the success. And of course, the more features you develop, the complexity goes up. So there's a lot of questions to answer here. Can we add a functionality super fast? Are we prepared to scale? Is it tough to maintain? What about technical debt? Because I'm not going to believe that here someone doesn't have technical debt or legacy code. We all have that. We have a lot of code. I'm going to show you some production code, which is super legacy. And we try to do things in a good way. And the question is how we can keep that code base healthy and clean, because we need to constantly improve it. And what about onboarding new people? Because in our case, we started growing from 10 developers to 20 in 6 months. So how can you onboard those people? They're new to the code base, but you still need to ship features. And product are not going to understand. They're saying, hey, you're 20 developers. So there's a lot of tricks, and I want to introduce a bunch of things that might wake up your curiosity. I just want you, when you go away from this room, you get something in mind, something out of this talk. Of course, I'm going to be around, and I would definitely love to continue discussing things, because I need to learn too. I do want to learn out of your experiences. And this is going to include team organization. I'm going to talk about how we organize teams, how all the mistakes we made around that too. So the first thing is if your code base is hard to work with, change it. If you see some part of the code that you're struggling with, just change it. Maybe it needs some refactoring. It needs another approach, another thing. So that's the point number one. And what happened at SoundCloud, we talk a lot about how we change our monolith to a microservice architecture and how we evolve our backend. I'm not going to show anything backend related here. I just want to show some tool that we are using. Let me see if this works. Oh, yeah, I think. Okay. No, it's not working. Hold on. Demo effect. So basically, this tool, it reads your GitHub logs, and set preferences. Let me go quickly. Where is here? Yeah. So I'm gonna change this just a little bit. Oh, yeah, there we go. Yeah, so we're here. I promise this is gonna be cool. All right, let's see what happens here. So we evolve our code. Please run. Okay, so that's super cool, right? Basically, what's happening here is you can see one guy contributing to our code base, right? Which is Sean. John is our tech lead now. And it's basically, you can see all the files that are being modified in a very graphical way, which shows you how much your code evolves in the end. And you see now it's John, and there's another new contributor, as you can see. You can set it up, you can put your pictures actually on those. It's super, super cool. And the good thing about it is just this is May 2014. No, sorry. This is actually 2011. But I could go here, and I could go even more. And you can see how many people now are contributing to our code base. And more and more. And you can see, how big your code base becomes here. And how do you deal with all these changes? Well, okay, so yeah, should be. That was a weekend probably. No one was committing too much code. But you can see now all the files, all the code evolution. So I definitely encourage you to at least, run this tool. I'm gonna send it to you. I'm gonna post it on Twitter. I'm gonna post it on my slides. But it's super nice to see that, and you'll be super surprised, how much you modified your code. And actually, it can give you some results like, what are the most modified files? Maybe that's where you're having conflicts. So it's pretty easy to use, actually. And let me go here. It's very easy to use. And actually, all right, so here we go. Yeah. So with that being said, and with all that being shown, I think you want to try it out now, right? It's very curious, right? So that's what I wanted to tell you, all this evolution. And what can we do then in terms of code base, in terms of team organization? Working culture is super important in these cases, and you will see because there's tons of people working in your code base. And some processes, like what happens when we onboard new people. In our case, we're pairing a lot, but I'm going to give you more details later on. And so we have a bunch of enemies for our code base. And I would say the first one is size. It's not about the method counting because that was solved already with a hack, but it was solved. But you can see this data is from a couple of months ago, actually. The number of methods that we are having and the lines of code, only without counting all the frameworks or libraries that we develop ourselves. And then there is another thing, complexity. The code is not there to just like be understood. It's only for the purpose of like showing that when you have something super complex, like, I don't know, going through a red-black tree, for example, try to hide that complexity in your code base. People will definitely appreciate that. And there is a couple of things, like flaky tests. We have a lot of flaky tests. This is actually production. So basically what we do, we have around like 300 UI tests, like 1,000 integration tests, and 5,000 more or less unit tests. So flakiness, it's there. UI tests by nature are flakiness because we're dealing with network connection and so forth. So what we do, we have someone which we call the test sheriff, which is a person that rotates every week. And basically, it's going to try to fix some flakiness around our tests. This is the message we see every day on Slack. So basically, we created a bot that is going to check those tests. And you can see the failure count here. And so this person is going to try to fix at least, a bunch of them and try to get rid of flakiness. Anti-patterns. I mean, this is actually production code. We are using an asyntax somewhere in the code. I was just typing asyntax, I don't think, and I found this. So, I mean, for me nowadays, this is an anti-pattern. I mean, we shouldn't be using asyntax on Android. I mean, super coupled to the UI. And we are basically using it, we are using HTTP URL connection here too. I think this is part of, I don't even remember, but it's been there and it hasn't been touched for a long time, and no one wants to touch that because it's going to break other things and so forth. So try to avoid anti-patterns. One thing that we are suffering from in our code base is what we call the lava anti-pattern. Are you guys familiar with that? Basically, the lava anti-pattern stands for, when you have so many ways in your code base of doing the same thing. So, for instance, you have someone new into the code, jumping on board, and then that person asks you how I should develop this feature. Is there any reference or any other feature I can look into and try to follow the same patterns? And someone is going to mention a feature, and the other person is going to mention another feature. So you have both, both are valid, which is the real truth then. So you have many ways of doing the same thing. That's something that happens when you're refactoring stuff. And try to avoid that. Technical debt. We have some specific, this is, yeah, again, I mean, there's going to be, the slides are going to be published. It's not about the details here, but basically what I can tell you about this piece of code is that we are using a singleton, but without a dependency injection, with the get instance method. And that's an anti-pattern. We are saving a state here, and I mean, it's still, we deprecate it, but still it's being used somewhere in the code. So this is technical debt. These are things that we need to clean up if we want to keep our code base healthy and sane. And the question is like, how can we get rid of all these things? The fact number two. Oh, Spanish. I'd say it in Spanish. I mix it up. Fact number two, architecture matters. It's very important. I've been writing about architecture, many things. I'm interested into that. And of course, like when you start growing, you will need a new architecture because most of the time your application might not scale. You think, you know, in a very small scale in the beginning, then when you have like many people jumping on board, that might not be enough and you need to re-architect your code. Sometimes it turns out that you need to rewrite some stuff. I can give you some examples between iOS and Android in our company. iOS actually, we were growing like crazy and our architecture was not supporting the amount of people that we had because there were a lot of conflicts. Many people would be touching the same part of the code, which leads to conflicts, and all the time, I mean, it's super tough to work with a code base like that. So iOS was inheriting a code base that was coming from an agency, and they tried to refactor it, but at some point they couldn't do it anymore. So basically they rewrote the app. On Android, we were suffering the same thing. It was a very painful code base, but we decided to just start little by little refactoring. And again, we needed a new architecture in that case. So many of you have asked me whether we are using clean architecture at SoundCloud. No, we are using something similar, I would say, but I'm gonna go back to that later. And what I would say, it doesn't matter which architecture you pick if that works for you. There's so many options out there. You can go for an onion layers, clean architecture, ports and adapters, I don't know, model view presenter. Yeah, by itself. Maybe you can have a custom combination, and that's what we have at SoundCloud. We have something that we call Spoker. Don't ask me why. I still don't know. But it's called Spoker. And basically, the only thing I know is the O of Spoker comes from operations, which is our domain layer. It's something similar to clean architecture, but we are not using any naming conventions. It's like our operation classes are kind of our use cases in a clean architecture approach. You can use, again, your own. Or maybe we use this approach. This is a concept introduced by Martin Fowler, which means sacrificial architecture is something that you know you're going to throw away. And so I would say for prototyping, just go for it. You know, just hack it up, and then you know that you're going to throw away and rewrite it. So what are the benefits? You're going to have a better and faster development, good scalability, consistency. That's, again, is one of the most important parts for me, because you should be able to go to any part of the code and should be similar to the rest of the code, like following certain patterns. You don't want to have, like, again, this lab anti-pattern, different ways of doing the same thing, or things in some place you use MVP and another place you use like MVVI or whatever. And so this is something, this is our mobile ecosystem now, and SoundCloud is in a big picture. So just wanted, became like, came from feedback that I got. People wanted me to show at least a big picture, and I'm gonna go quickly through this. We have our mobile clients. So we have two mobile APIs. which we call BFFs. This is a pattern that we create. I don't know if we created, but many people wrote about it at SoundCloud, which is called backend for frontends. So basically, this is a layer on top of our microservice architecture. We have around 150 microservices, which is our backend. And now that since we need to maintain two APIs for both clients, for our mobile clients and for our web, we are doing some tests with GraphSQL. So we want to merge, let's say, these two APIs, and from the clients use GraphSQL. This is in a big scale what we're doing. This is something. Again, it's not about the details, and then you can go if you want to through the details. But this is an activity in our app. What I'm trying to show here is that our activities barely have logic. This is an activity, and it must contain, I don't know, 50, 60 lines of code or whatever, because we are trying to run away. We don't think in terms of Android. We think in terms of a good architecture. We think in terms of abstractions and so forth. We are using presenters here. This is a fragment, actually. You can see, I mean, it's even smaller. So, yeah, I mean, dive into the code if you want, but like this is not very important because we don't want to rely on Android in this case because Android classes are tough to test and so forth. So we're running away from the framework. So fact number 3, you need to constantly refactor your code. We're all the time refactoring our code, acting as good Boy Scouts. Like, so whenever you see something that is bad in the code, just go and refactor it. Explore new technologies. Now we are migrating from RxJava 1 to RxJava 2. We got some new benefits. Of course, I can give you more insight if you want about how we are doing, because it's a super big code base. So we are taking really baby steps here and take new approaches. I mean, if what is there is not working for you, again, just change it. And this is a quick example of like being a good Boy Scout, because sometimes, I don't know, you need to evolve your code and be a good Boy Scout in baby steps. So let's put a quick sample here. So what's going on here, this is clearly breaking one of the solid principles, which is the open-close principle, which stands for that the class should be open for extension and closed for modification. What happens when you add a new processor here, and this is just a simple example, you will need to come here and touch your domain logic and add a new processor. So basically, create abstractions, always abstract things, so you don't need to touch your domain logic. So you will go for an abstraction here, a key processor. You have somewhere all your processors there, like let's say in a map, and you're going to add here, but this is not affecting your logic in the end. This is just containing a bunch of processors that are going to be used here. So you're going to loop through that map actually, and you don't have to touch this class anymore when you're adding a new processor. So basically, always refactor and be a good citizen, let's say. The thing is, like, in order to refactor stuff, you need to have tests. So how many of you write tests here? Okay. For all of you that are not writing tests, please do it. It's a lifesaver. I mean, I wouldn't touch a code base that doesn't have tests. At least I would try to write a few of them. Because, I mean, how can you, if you're refactoring something, how can you make sure that you're not breaking anything? So always rely on a good test battery that backs you up. What happened with legacy code, technical debt? For me, legacy code is, something that you cannot read in your code base, something that is tough to scan. So for instance, that includes anti-patterns, legacy code, of course. Abandoned code for me is related to legacy. It's something that hasn't been touched for a long time, as I showed before, with all these async tasks. And code without tests. I mean, if you're writing if you're adding more code to the database, for me that's legacy code, because there's no way to assert any behavior from my side. And there were some discussions around, like, talking to Anton somewhere, and about like code coverage and other guys. For me, code coverage is just a number, because you can increase code coverage by just testing setters and getters. So, I mean, and that's not important. What you want to test is your domain logic. So, how do you tackle technical debt? We use something that we call technical debt radar. So, do you guys have any technical debt meeting? I mean, the ones that had that were working with many Android or iOS developers. Do you have any, for all of you, any meeting? How to address technical debt or something like that, or you're cleaning on the go? I would definitely be interested in listening to that. But yeah, we basically do what we call technical debt radar. We use also static analysis tool. It can give you some information about, all the parts of the code that hasn't been touched for a long time, for example. So, but what is a technical debt radar? So basically, we have a meeting as a collective, as a platform team, let's say Android, and we said, all right, we're going to draw this thing on the board, and we're going to start writing notes about like where the painful areas of our code base. And here are some examples. I mean, our data layer nowadays, like, we are refactoring because it's not scaling anymore. We have a big database, actually, and our idea is to just split it up, and each feature or each module in a big scale will contain its own data. So those features can live in isolation. But probably I'm going to write about that when we are done. Because we don't know still if that's going to work. So that's why, you have to try it. And then not most of the time, but sometimes it doesn't work and you try a new approach. So basically here, it's like we're saying, like, all right, so the x-axis represents the development time for something. And this represents how painful your part of the code is. So for instance, let's say, all right, so data layer is very painful because it's something that it's really important for our app, right? And dependency injection, we are, thanks for the talk today, it was super interesting, but we are still like having some issues because we are not scoping very well. And back in the days, we were creating this huge dependency graph when the app starts, and we were consuming a lot of memory. So that was something that was causing a lot of pain, but it would take a lot of time to fix it, right? So with this graph, we are basically saying, all right, maybe we need to tackle things that are like causing a lot of pain, but are not hard to fix. So for instance, login is causing some pain, and but it's not that hard to fix. So maybe that's going to help you to say, all right, let's kill this part of the code. Let's try to fix it. The other things probably will require more planning or whatever. But this is basically a simple way to just go to a meeting and just like work together and say, all right, let's kill this. Let's clean it up. Again, code readability. This is super important. And there's a bunch of quotes from let's say Martin Fowler or John Woods, which was this famous quote about like write code as, if the person that is going to read it is a serial killer that knows where you live. So try to favor readability over performance. Sometimes we love to like make code better to make it more performant. But first, I would say, if that's not critical for your business, it's fine. Just go for readability. I mean, I would say like if you need to do some real-time ATM application, whatever, something that it needs to perform super fast, maybe that's a good way to think about performance over readability. Although I would argue a little bit. So performance, something that I really like, always measure, because sometimes we say, all right, I'm gonna like make this faster, but you're not measuring anything. And now we are working on some monitoring of our Android app. We have planned to open source something, but it's still a work in progress. We want to have something that you can say, all right, just implement something, and it's a framework basically where you can measure specific things of your app, and you're going to get some stuff for free, like network calls, network requests, or application startup time shown in a dashboard. But we're still working on it. Of course, encapsulate complexity. Again, if you're like working on a new algorithm, just encapsulate it and put a good naming for that, and whatever happens there, it's just like a black box. And monitor it. It's super important that if you're working on some performance improvements and you want to see the progress of that. There's another thing regarding big code bases. We have two apps actually. I don't know if many of the people out there know about it, but we have like a listeners app and creators app for music creators in order to upload their tracks and so forth. So we need to share common logic here, and we have a bunch of things that we have created. So we have something that we call Android Kit, which includes all the presentation logic and all the stuff that comes from the framework. Like let's say recycler views. We have our own base presenters there and things that to keep consistency. So if you grab one app or the other, I mean, it's going to be consistent. You will see both using kind of the same patterns. We have Skippy. Skippy's our music player. It's a C++ library. So we use it for both iOS and Android. And yeah, it's developed by a separated team. We have like Cycle. This is something that is going to forward. You can inject, let's say, light cycle elements, let's say presenters, and what's going to happen there is like where that presenter, if that presenter is injected into a fragment, let's say, all the callbacks from the fragment life cycle is going to go to the presenter. So you don't need to deal with any logic inside the fragment. You will do it inside your presenters. We have Propeller. Propeller is our attempt to have a reactive library that's going to convert our SQLite objects, or what are these called? This thing that returns Android. Okay, I forgot. Cursors. Yeah, I hate them. So because you always forget to close them and so forth. So we encapsulated that into a library that's going to meet items, going to return observables. What else? Automation. As I told you, I made this mistake. This is the story I told you. It was because it was a manual step. And if you forget doing something like that, you can really screw it up. I don't even want to know how much money we lost during that time. People not being able to play, or like serving these millions of users with 2 Mac Minis. So you need to work on something like that. At some point in time, you need to work to have your continuous integration environment. We have, of course, continuous building, continuous integration, and continuous deployment. Actually, our process is actually we never go to Google Play. We just do everything from Jenkins, in our case. Just wanted to recap a little bit and tell you lessons learned so far from my experience. I would always wrap third-party libraries. I mean, you cannot wrap RxJava, of course, but like when your HTTP client, for example. Try to not overthink. Sometimes we want to create like the best architecture ever, and we are doing over-engineering, and that includes me. I mean, when I started writing about clean architecture, many people say, but yeah, man, but that's super complex for a list of items, because the example was a list of items, and you would just click on an item, it's going to show the details. And it's just like, well, I mean, that was not the purpose. I mean, the purpose was to scale that. But many people say like, man, I don't know, I wouldn't do that for a list. No, I wouldn't do it either. But it was just for learning purpose. So try to not overthink. I mean, you can later refactor and get better at that. But don't forget to do that. And early optimization is bad. Don't think about that too much. Try to think in terms of readability, good scalability, and so forth. And trial error does not always work. The fact that you're with a true value in a flag doesn't work. I mean, if you put it to false, probably it's not going to work either. Try to debug more and divide and conquer. So whenever, sometimes we're given a super complex problem and we tend to think, holy crap, how I'm going to solve this problem? And just like you need to start thinking at a smaller scale. Just split up your problem, and then like, in little pieces, you're going to start solving them, like, step by step. And prevention is always better than cure, of course. Another thing, you need to work as a team here. I mean, I know that you guys we like to write super nice code by ourselves, like try things out. But what happens when you're working in a big code base? You need to sync with other people. You need to communicate well. Otherwise, it's not going to work. And I'm pretty sure the people here who are working with big teams understand that better. So I'm going to show you how we organize our teams. Again, we're 20 in each platform. So we have a platform tech lead. Basically, this is the one that knows pretty much, or at least this person has the big picture of the code base. So he knows, or he keeps in mind, where the painful areas, what needs to be improved. We have a core team. I'm part of the core team. Basically, we take care of all the cross-cutting concerns of the app, so which means things that affect the entire app. Let's say, again, dependency injection, data layer. We work super close to the tech lead. And we have feature teams. I mean, in my case, my users are other developers, so I basically provide tools to other developers. And it's super nice because I have them on site. They can punch me, right? I come over to my desk and this is not working. So those are my users, basically. And we have, of course, we are kind of lucky, of course, because we have a test engineering team. I know that many companies cannot have that, but sooner or later you will need testing support, just let's say for your continuous integration environment or whatever. This is pretty much how it's working now. So let me quickly go through this graph here. So this is core engineering, which includes engineers from both iOS and Android. And we maintain the mobile API, which is developed under Scala. There's another curious thing, just out of curiosity. We were using, the other day I was counting 20 different programming languages in our I think that's too much for me, but still could be an anti-pattern sometimes, because it's nice to touch Haskell, it's nice to touch Ruby, Python, Scala. Most of the time we're doing Scala, but still, I think it's too much. Go. And so basically, we have test engineering, which works with us in everything that is cross-cutting concern. Again, we have the tech leads, which work with the collective platforms. When I say collective, it's not an official team, but you will need to work as Android and iOS. Even though you have feature teams in your company, you will need to solve problems at a platform level with all your Android or iOS developers. So the tech leads basically have the big picture of the requirements of each platform, and the tech lead is going to communicate with us, and of course with testing engineering, but this is a more direct relationship. And basically test engineering is going to create tools in terms of testing for both Android and iOS. For instance, our UI framework, actually, it was created by the test engineering team. And it's super cool because when we have a test failing, it records a video of where it failed. And it's going to send you an email, and you can see exactly where it failed and what was the current state of both the device and the app at the moment. We have feature teams. Now we call them clusters because we try to go for a feature teams approach, and at some point I remember myself being super overloaded because back in the days, we were not enough mobile developers to cover all the needs for all the teams. And at some point, I ended up like working for 3 or 4 feature teams, and it was super crazy. There was a lot of context switching, and we decided, all right, this is not going anywhere because all of the developers are completely overloaded. So that's basically our team organization and our working culture. We do pair programming, and I definitely encourage you to do it. 80% of our time we are pairing with someone. 80%. Which is great because you get a lot of stuff for free. You get you can transfer knowledge. So, for instance, when there is someone new, we just sit down and pair with that person. So that new person is gonna start jumping, and start pairing with all of us. So this person is gonna have a strong knowledge of the entire code base. There's a lot of things that you can do. I mean, we actually have a plugin for IntelliJ. It's like a video game, actually, and you can, score points. Usually we have 2 keywords, and those points are, related to the number of lines of code you write, or, how many tests you write. I will give you some more information. It's super funny. You can make it super fun in the end. We use, of course, a Git branching model. This is very important because we tend to work like in isolation as Android and iPhone, and in the end we are facing the same challenges. I mean, if there is a feature parity, I mean, you might face the same challenges. Of course, the platform are a bit different in specific cases, but like the problem to solve it should be pretty much the same. Of course, each team is free to choose any methodology. We are not tied to any specific methodology. Of course, I'm not a strong believer of agile frameworks, let's say Scrum or Kanban. I think they should adapt to your way of working and not the other way around. We shouldn't, adopt them and follow their rules. But this is personal opinion. We have a collective sync meeting. This is where we kind of solve all the platform-related issues. And we have, of course, processes, onboarding new people, as I told you, pairing. I think this is super important. Hiring people, we take an important part of that. So the interviews actually are being done by us, because in the end, we are going to work with this person. It's not human resources who's going to work with this new person. We have the sheriff, as I told you before. This is our way of releasing. We use release trains. Do you know what a release train is? It's really a release train model. Yeah? Okay. So for all of you who don't know, it's like basically you have a release train means that you have the train depart in every specific amount of time. Let's say in our case, between every 15 days. So the train departures. So which means we ship a new version of the app at this point. And what means like all the features that are ready for production, jump on the train and are shipped. If there's something that is not ready, it must wait the next train, which is happening in 15 days. So I think this is working pretty well. Again, we have people that rotates for every train, let's say, and that's what I was like when I screw it up, a release captain. This is very important too, just use your own app. I think it's very important. It's called dog fooding. I mean, the term of like, eating your own food, let's say. And we use an alpha for that. And so where we tried stuff and we prototype and so forth. We have a beta community too. You get really valuable feedback if you know how to use it. We have around 3,000 people using our beta version of the app, and they're really active, but you need to care about it, because otherwise you just ship a version of the app and you just leave it there. I mean, they will feel like alone. They will need more love. And so you will have to deal with it. So in order to recap, this is what I wanted to give you a bunch of ideas how we work. I know that maybe you were expecting more like deeper things in terms of code. For me, it's like these are key things, and you need a lot of things that need to work together in order to have this harmony and things. Otherwise, trust me, like if you're the best developer ever, but you're not a team player, you're not a good voice scout, you don't have all these things in place, I mean, your code is not going to scale anyway. So again, if your code is hard to work with, just change it. Architecture is pretty important, and I'm looking forward to talk about architecture with many of you. I think many people approaching me. I'm going to be here right after the talk or tomorrow, and we can code and do some hacking together. Yes, we need to constantly improve our code by refactoring. Write tests. That's super important. Again, today there were super nice test talks. Tackle technical debt. Don't make it like a snowball effect, like which at some point is going to blow up. It's just like you need time. You need time to like keep your code base healthy, and try to like write readable code, because other people in your team are going to appreciate that. When you see like, let's say like for me, it's like when you look at some, I don't know, Square library, it's just like it's, writing code should be like art, it's like in the end, I mean, you see that code and it's just like, it's super easy to understand. Well, not in 100% of the cases, but they write really nice code. We have GitHub where we can get examples from the biggest code base ever. Share logic all the time, like whenever it's possible. When you have several apps, like in our case, you will need to do that to encapsulate things, pull them out, and share it. And create a good continuous integration environment and try to automate as much as you can. As we said, we try to not do anything manual. We don't have any manual testing, only half an hour before we ship a new version. We rely on our tests in order to do that. And we saved a lot of time, and we think that the quality of our apps, it's a very decent, it's good. And work, of course, as a team. If you have a big code base and you're not working as a team, you're going to struggle a lot. Conclusion: use solid principles. It's not that hard. Like, try to understand them. And what we do as developers should be fun. I mean, there is a one-to-one relationship between having fun and getting things done. So whenever you're having fun, I'm pretty sure you will get things done. And of course, so if you're not having fun, maybe you're in the wrong place or something's not working. I think that's pretty much what I have to offer. Just wanted to give you a big picture of how to work with big code bases. And I'm looking forward to questions and to catch up with all of you right after this talk on tomorrow. Thank you.
Thank you for the speech. Any questions? Hello?
Hello.
Thank you for the presentation.
Welcome.
My question relates to the thesis that unit tests support us when we are doing refactoring. And I agree on that to some extent. But it's absolutely okay when we do small refactorings or adding some features, slight extensions. But as we are trying to make a little revolution in our code base to change everything completely, I think it's not really true. And I'll give you an example. Suppose one morning you wake up and read an article about a new silver bullet architecture. you understand the layers, the entities, their interconnections, and you think that that's exactly what you've been looking for the entire time of your long career.
Yeah.
And you're trying to instantly migrate from your current architecture to that. And your code base, suppose it's well properly covered with unit tests. Every single entity is greatly covered with unit tests. But as you're trying to abandon those entities, your unit tests are no longer valid and relevant. So, do you have any personal recipe for doing such code-based revolutions?
I would say that whenever we need to do something big, first, we don't accept PRs bigger than 500 lines of code. I mean, no one is going to review, because you know, like, what happens, like, when you see a PR of like 10,000 lines of code, it's like you're just scrolling, just like you're not understanding most of it. And if you send like a small PR, like 10 lines of code, everyone's going to find something. So the thing is, for us, I think in that case, when we re-architecture something, what we do is like, let's pick up one functionality of our app end to end, let's say one screen, separate it, and do it with this approach, in this way. So if you don't have unit tests, maybe you can have a UI test that goes end to end to that functionality. And so basically you would use the new approach, see how that works, you know, end to end in one screen of your app. And then if that's what you want, if you have like, you know, a good architectural approach, then you start refactoring in baby steps. You don't want to change everything, because you don't know how your code is going to react. Especially you can, you know, screw everything up in your code. So I would definitely say, like, always do it step by step. Our take with RxJava 2, I mean, our code is, let's say, polluted with RxJava 1, and we are using it all over the place. And what we did in core is just like, we picked one functionality end to end, and we migrated to RxJava 2. Then what we are doing is like, all right, guys, we're going to show how we did it, and let's, as a collective, let's start refactoring little by little, trying, testing stuff, maybe one new functionality within every new release, because you cannot do it like in one shot. It would be crazy. I think like no one will understand your PRs, and it's just like, imagine 20 people contributing that day, and you have your PR there. It's like whatever, you know, someone touches is going to have conflicts within your PR. So I would say that, like, just pick one end-to-end feature, just do it, try it, test it, and then just show it to your team. That would be what I would do.
Yeah, thank you again for your presentation.
You're welcome.
I have a question about product documentation. So, for example, when we have a lot of features, we have to know how each feature should work. And so my question what do you think the best way to keep up to date the product documentation from your point of view, and what do you use at SoundCloud? Okay,
so I would say like when you write code, it should be documented by itself. That's why I was like saying, because you know, usually documentation tend to be out of date. It's super tough to maintain. So that's why I was like, you know, encourage people to just write readable code. So you can go there and read the code. For public APIs, of course, sometimes you need documentation because you want other teams to use that. Of course, I mean, we try to make sure when you modify some contract or some public, or you're a new method to any public API or any library, we try to make sure that it's properly documented on PRs. There's not a magic bullet for that. And that's what we do at SoundCloud. And we don't put comments on our code. And yeah.
Yeah, and I mean about features documentation, like, for example, the use case of, let's say, the login screen.
Yeah.
So how it should work. So do you use flowcharts or maybe some text description? I mean, before the developers start to code this feature.
We have like a big picture of like what our architecture is like. So for instance, it's the same as if we were using clean architecture. You have like a big picture, like from the use case, from the presenter, which contains a use case, and then it contains a reference to the view, and you have only one picture, but it's not related to any functionality of your code. Then by knowing the architectural approach, you should be able to go to the code and say, oh, this is my presenter, and there should be some use case inside. So whenever you have knowledge on your code base, and that's why, for me, consistency is important, because you have only one way to do things. Of course, it could be slightly different in specific places because of specific requirements, but that's why consistency is important. It's easy to understand once you get the big picture. Yeah, that's all I can tell you. We don't use much any graphical toolings for that, because it's usually that's what happens. It gets out of date, and from my perspective, that is even worse than having no documentation at all. Yeah, you're welcome.
Hi, my name is Arthur. I'm here.
Okay, cool, man.
Yeah. And I have a question about sharing logic. So, how, when, and who should decide if this code can be reused by other people first? And second, when this logic is extracted, usually there are different cases needed for different users, for different developers. So we start to have one parameterized function, second, third, and so on. So how do you do this?
I mean, that's a collective decision. I mean, when we decide to extract something that is going to be reused across different code bases, we basically, the tech lead, kind of, probably create a meeting with core engineering, because it's something super core that, all this sharing logic. So we make the decision. I mean, it happened to us like many times because of this change of requirements. You need a new method, and at some point we just push back what we were extracting because it was not useful for the other code base. We try to keep things that are really going to be shared. Otherwise, we just put it inside our both apps. Yeah.
So you have some maybe point of week when you say that, okay, today we updated this corp function, everyone pay attention to this change.
No, I mean, if we update something, we try to keep it backward compatible first. And of course, I mean, that's a rule for us. We need to do that because maybe that function is being used across the code. Maybe we deprecate it and we say, all right, as an optional, try to use this presenter rather than the other one. But I would say it's like kind of a core decision, and we always showcase it. I mean, we have these collective meetings, and that's our opportunity to say, all right, we changed this because this performed better or whatever. And then we show it and we deprecate the other things. And again, like when you see a deprecated method, then you might, whenever you see it, you might refactor that part of the code and go for the new approach. But we use a lot, deprecation. I mean, when it's needed, basically. Yeah, you're welcome.